All right, so normal distribution. We talked a little bit about that with the groups last week, or I guess before Christmas, and now we're going to talk about it more in depth. So here's how this is going to work. When we talk about normal distribution, you know that that with a normal distribution, the data, 68% of the data falls within one standard deviation of the mean. And the reason that says 34.13 is because it's splitting it in half. Okay, then 95% fall within 2 standard deviations, and 99.9% fall within 3. So what we're going to do is we're going to talk about how do we find probabilities if we're given standard deviations. Okay, so for example, if I want to know what's the probability that a set of data will fall from 0 to 2, somewhere in this 0 to 2 standard deviations. Well, then I would add these two probabilities together, and it would give me that number. So today what we're going to talk about is strictly if you're given a standard deviation, which is also called a z-score. Okay, it's a z-score. If you're given a z-score, can you find the probability of an event occurring? Now, this is very, very, I can't think of the word. There is an exact method for each one of these. So it's actually pretty easy to do if you follow the steps. And the steps are all in your book, and I'm going to go over them all today. There will be no practice problems. There's examples that you have to do, but there are no practice problems. So, and there's actually 7 different possibilities for finding probabilities using z-scores. So we have to go through all 7. So let's look at the first one. The first one's an easy one. I have to wait for it to get to that point. My video here, but so the steps really quick as we talk about this. The steps. The first step, anytime you're given a z-score, is you need to draw a picture because we need to look at what are we looking for. So your first step is to draw a picture, and I would actually recommend you writing these steps down. First step is to draw a picture. The second step is to shade whatever area we're looking for, because what we're looking for is an area underneath the curve. Whoops, let's go back. What we're looking for is an area underneath the curve. The third step is to follow the procedure table, which we're going to go through each step. There's 7 of them. Okay, we're going to follow the procedure table, and then we're going to find the area. So, going on to the next step. Okay, so the first one is what happens if the z-score that they're given to us is between 0 and the z. This is the easiest one to find. So if it says, I want to find the probability that the z-score is between 0 and 2.32, meaning that I want to find the probability that that any given value is within 2.32 standard deviations of the mean. What's that probability? And so this is what it looks like. So if I were to draw my picture, and I hope I drew pictures when I was doing your notes here. Let's see if I did. If I were to draw my picture, I'm looking between 0 and 2.32. So this is the area, and I'm going to shade that area in. Okay, that's the area that I'm looking for. And so now, once I know what this is, now I can follow the step. The step says between 0 and any z value, I'm going to look up the z value on the table to get the area. So here's my table, 2.3 down here, and then my O2, 2.32. And I go to my number, and it says 0.4898. So my area, or my probability, is 0.4898, or 48.98%. So this is really important that you follow the table. Now you'll be given this table. This is the first of many tables that we'll use. So that's number 1. Number 2. Okay. So number 2, if you look, it's saying I want to find what's the probability that something's bigger than a z value or smaller than a negative z value. Keep in mind that both of these are the same thing. So if my probability says z is greater than 1.91, meaning that I want to say what's the probability that a value is more than 1.91 standard deviations away from the mean, and just the positive value. So what I do is I have to look up the z-score. Again, all of this is going to involve the table. So I will look up the z-score. Well, I draw my picture first. Always draw your picture. So did I go? So I'll draw my picture, and it will show that I'm looking for a tail. So in our tail here, so it's 0, 1.91, and I color in the tail. And then I look it up on the chart, 1.91 is going to give me 0.4719. Now, what this is telling me, it's giving me the area that's in here, but that's not what I want. This entire area is 0.5 because the whole thing is 1, right? So I go 0.5 minus 4.4179, and I get 0.0281. So the probability that my z-score is greater than 1.91 is 2.81%. So that's the second one. Again, these are fairly simple, but you have to make sure you use the right method. Now, this one is between two z-scores. This is a little complex. Is what if I'm looking between, say, 2 and 2.47, and I want this area here. So I have to find, in this case, two areas on my chart. So what I'm going to do is I'm going to look up 2 first, and then I'm going to look up 2.47. Now, what's really important to note is that these are on the same side of the 0. If I had one on this side and one on that side, then that's going to be a different value. So what I have to do is I have to subtract them from each other, and that will give me the area in between these two. So this in case was 0.4932 minus 0.4772, 0.016, which is 1.6%. So let's go back just a little bit. I want to make sure. So my area that I'm looking here is this area subtracted from that area. So I'm not taking the z-score minus the z-score. I'm actually looking at areas, at probabilities. So, and I know this seems like this is complex, and I understand that, but this is just the beginning. This is saying you may not understand what these scores mean, you may not understand what these areas mean, but if you're given numbers, can you find them? And we'll worry about applying them next time. This time I just want you to worry about being able to use the chart and use the table. So next one that we have, number 4. Okay, if we want to go between two z values that are on opposite sides, so one's negative and one's positive. These are actually fairly easy. We want this area and that area, and we're going to add them together. So let's draw our picture here. So I have a z-score of 1.68 and a z-score of negative 1.37. And I draw these charts, they're really easy to draw, and then I shade in what I'm looking for. I want that area between. So since it looks like this, I'm going to use these steps. I'm going to look up the z-score for 1.68, the z-score for 1.37. Note there are no negatives, okay? It really doesn't matter. It's still the same number. So I have 0.4535 and 0.4147. And what I'm going to do is I'm going to add those together because that's what it tells me to do. I'm adding these two areas together to get the area of that entire space. 0.8682, or 86.82%. So that's the probability that my value will land between those two z-scores. All right, this one. So if I have, now this is kind of tricky to draw the picture of, all right? So I have the probability that z is less than 1.65. So I put 1.65 here, and I want to go everything that's less than that. So I color everything down there. And I go to my chart, and I realize that this is what it looks like. So I want this area and that area. Keep in mind that this whole area is half, and then I get whatever this is. So 1.65 is 0.4505, and this area is 0.5, so I'm going to add them together. That gives me 0.9505. Or 95%. So this is actually a pretty big probability that something will fall within that z-score. Okay, now this one is almost the exact same thing. It's if I have it to the right of the negative z. So I draw my picture. If you get your pictures right and you can match them, it's fairly simple to do these. So then I color in that area because it's everything to the right of negative 1.16. Then I look it up. 1.16. 0.3770. plus 0.5 is going to give me 0.8770. So it's 87.7%. Okay. Now, the next one, and this is the hardest one. This one takes the most work. All right, the very last one. There's no more after number 7. Okay, so this one. I want to look at this for a second. I want to know what is the probability that my value lands in here or here. So if I do this, I have to add these two together. But remember, to find a tail, you have to subtract from 0.5. So we have to subtract both of them from 0.5 and then add my answers together. So let's look at how we do this. So I draw my picture first to make sure this is really what I'm looking for. To the right of 2.43, and I color that, and to the left of negative 3.01. Color that. Maybe I took too long to color that. There we go. Alright, so I colored these. So these are the two that I'm looking for. They are two tails. So if I have two tails, I have to find both values. 2.43 first. It's 0.4925. And 3.01 is down here underneath my thing. Sorry. See if I can get that to go away. Anyway, subtract from 0.5, and then I'm going to subtract from 0.5. So that's what I do first. I subtract my values from 0.5 first. So I get 0.0075 and 0.0013. And I add those together to get me the area of both of them combined, which is 0.88 or 0.88%. A very, very small probability on this one. And that is it. That is our lesson today. So make sure that you have all of them written down, all the examples, and we'll come back tomorrow in class, and I'll do a quick review. I probably won't go through every single one, but I will do a few of them, and then we'll do these in class. It's not very hard, but it is hard to to put them all together in some ways. So see you tomorrow.